6, here we come. We got to determine whether it's a polynomial function or not. Probably the easiest way to refresh your memory is that polynomial functions are smooth and continuous. Remember, they look like this. They could go down like that, quadratics. But anytime there's a vertical asymptote or there would be a hole, any issue with the domain, it's not a polynomial function for sure. So this first one right here, if we were to expand this out, you would get something that's f of x to the third equals x to the third power, because that right here would FOIL out to x squared. Multiplied by that, we would get an x cubed. This is a polynomial function, so this is right here, and we would say that the degree is 3, because it says state the degree. All right, this one here, that's actually x to the 1/2 power. That makes it not a polynomial function. Also, you can't take the square root of negative numbers, so there's going to be a whole section of that graph that's not graph, so not a polynomial function. This one is, there's no issue with the domain, there's just a 4, everything's good there. If we wanted to rewrite it, we could rewrite it as 1/4 x cubed plus 7/4, just to show that is a polynomial function. So we would say yes, and again we would have a degree of 3 for that problem. Okay, cruising along, try to refresh our memory with how we actually talked about the zeros and multiplicities. The zeros, again, we've learned this year, are the x values that make 0. So if I put a 0 in here, if I put a 2 in here, or I put a -5, all of those values will create 0 for our function. All right? The power on the 0 is called the multiplicity. So 0 has a multiplicity of 1, this 2 has a multiplicity of 3, and that -5 has a multiplicity of 2. And then we know by their multiplicities whether they cross or touch. All right, so if a multiplicity is odd, like these first two, those are going to cross. So we got cross, and then we're going to touch whenever there's a multiplicity of 2. It also asks to state the degree, so I add up all of the multiplicities in its factored form. So 1, 4, and 2 makes a degree of 6. Okay, likewise 48, we have -8, -1, and +4 for our zeros. Got a multiplicity of 4, so that's going to touch. Got a multiplicity of 1, that's going to cross. And then a multiplicity of 3, that's going to cross. The degree on this one would be equal to 4 plus 1 plus 3, which is 8. Constructing a polynomial with given zeros means just kind of going the other way. All right, so they told me the zeros and they told me the multiplicities. So I'm just basically going to put a x minus 5 as a factor, because if 5 is a 0, then x minus 5 is a factor. Power of 3 for the multiplicity, x plus 2, multiplicity of 2, and then x minus 3 with a multiplicity of 1. On this one here, we typically will see this 0 written first, so we're going to say just x right there, and then we can put the other ones in. X minus 1 multiplicity of 1, x plus 3 multiplicity of 3. Okay, now that we got the goods down and we remember all of that, we're going to go talk about how to sketch. So we have a, just like before, in the last two problems, we have a 0 of 0, multiplicity of 3, and it's going to cross. Okay, then we have a -2, multiplicity of 2, and it's going to touch. And then we got -5, multiplicity of 1, cross, and a 1, multiplicity of 1, cross. So filling those out here on our graph, we should be able to determine the shape of this, polynomial function. Okay, so now we go to 0 right here, and we're going to cross, so I like putting a little c there. Go to -2, we're going to end up touching there. -3, 4, -5 here is going to be a cross, and then at +1 here is also going to be a cross. Next thing you want to look at is, what does the power function resemble? So basically, this is going to look like either x squared, x cubed, x to the 4th, something like that. Well, this one is actually going to be x to the 3 plus 2 is 5 plus 1 is 6, x to the 7th power. So we know that the left side's going down and the right side's going up. The y-intercept, if we have a x out front here, that means if you put in a 0, you will get 0. So the y-intercept for this one is going to be at 0, 0. We already knew that because we had our 0 there, and there's only one y-intercept. All right, so shaping this up now, basically I start with the ends, okay? So to get a nice color code here, whoa, that was really bad. I'm gonna try again, okay? So basically it's very steep, but it goes like this, and then this end is gonna go very steep up. So what do I do right here? I gotta make sure, I'm gonna change colors so you can see this. I go ahead and I cross, and then I come down and I touch, go up, and then I cross, and then I cross again. So that's your function. I'm keeping the blue as the ends because that's where I start. Okay, I start with the end behavior. All right, well, we should be able to graph these if we have them in factored form. So there's different ways of getting to factored form. Well, this one right here, I would love to pull out a GCF, but I don't have one. Okay, so I can't pull out that GCF here. So what I got to do is kind of think about these potential zeros we've been talking about. So if we look at the factors of 16, 1, 2, what else we got? 4, 8, 16. These are all factors of 16. We think about this thing called plus or minus P over Q. Well, Q is all of the factors of the leading coefficient, which is 1. So now I'll write this in blue. These are all going to be divided by 1. These are all of our possible zeros, potential zeros. It's really plus or minus 1, plus or minus 2, plus or minus 4, and so on and so forth. So basically what we do is we just pick one of those. Okay, we're going to go over here. We're going to try our synthetic division. I got a 1 for the coefficient. Don't forget your 0 for the filler. Negative 12 and negative 16. I need the filler because I don't have an x squared term. Okay, so then I'm going to do my synthetic division here. Well, I carry down the 1. Oh, I forgot. We got to actually check something. Okay, so we can pick anything. We can pick 1. Sure, let's see if it works. So 1, this is in red. 1 times 1 is 1. Add down, I get 1. 1 times 1 is 1. Add down, I get negative 11. Multiply back, I get negative 11. This is not coming out to 0. If it doesn't come out to 0, that means it's not a 0. So I'm going to start over. How about a negative 1? Let's try that. So 1 times negative 1, negative 1. Negative 1 when I add down, multiply back, 1. Negative 11, positive, nope, not working there. So that just tells us 1 and negative 1 are not zeros. Okay, so we got to try something else, and I'm just going to keep going down my list. All right, 2. So that'd be a 2, 2, 4. Negative 8. Negative 8 times 2. Negative 16. Ah, that does not add to 0. So that was really close. So negative 2 might work, right? So negative 2. Add down. Positive 4. Negative 8. Positive 16. And we got ourselves 0, which remember that makes us happy because what it did is it just told us one of our factors. So since negative 2 is a 0, x plus 2 is a factor. All right, so what's that mean? Well, now we take this part and we power down. Since it started at x cubed, now I'm at x squared minus 2x minus 8. Remember, I'm not taking the time to teach you from scratch here. It's just to hopefully spark your memory of remembering this. So x minus 4, x plus a 2, looks like that will work out. Well, what that just did was give me another factor of x plus 2. So there's my multiplicity there. And then we have a factor of x minus 4. Whoa. Now, zeros, multiplicities cross touch. We got negative 2, multiplicity of 2 touch. So negative 2, and it's going to touch there. And then we also have 4, multiplicity of 1 cross. So 1, 2, 3, 4, multiplicity of 1 cross. All right, so what do we do here? We look at our end behavior. The end behavior is f of x equals, well, that's simple when the problem is not factored. So that's just x cubed. So down and up. So that's going to go like that and like that. So obviously if I finish this, I'm going to touch, come down here somewhere, and then cross right there. So that means my y-intercept should be 0, negative something. Well, think about it. If I put in a 0 here, 0 cubed, minus 12 times 0, 0, minus 16, it is going to be a negative 16 right there. So the y-intercept is 0, negative 16. Alrighty. Okay, what do we got left here? We got basically one more problem here, and then the potentials, which we can talk about again. We've already kind of talked about that. This one's nice in the fact that I don't need synthetic division. The whole goal is to get this factored, so I can notice right here, all of those terms have an x in it. So I can pull an x out. And if I pull an x out, whoops, then I can factor just this part right here into x plus 5, and then x minus 4. All right, so what do we got? We got positive, looks good. Okay, so polynomial in factored form, that's this right here. All right, so what's that mean? That means we have a 0 with the multiplicity of 1 cross. That means we have a negative 5 multiplicity of 1 cross, and then a 4 multiplicity of 1 cross. So right here we're going to cross 1, 2, 3, 4, 5. Right here we're going to cross, and 1, 2, 3, 4, cross. We've already got a 0 of 0, so that's also a y-intercept. And this is once again expanded at the beginning already as x cubed. So we know this graph's going to go down like this. Cross, come down, cross, go up, cross, and there you're supposed to hit that point. Okay, one more that I'll do of these, and then you can check the solutions on 55. But like I mentioned a couple problems ago, plus or minus p over q is what we're looking for. So what are the p's and the q's? Okay, so this right here is the q. So that's 1, 2. All of the factors of that leading term is the q. Then we have all of the factors of that one, but that's the p. So we got 1 and we get 5. So every combination of this, be very careful, it's not everything, it's whatever p over q is. So these are the numerators, the p values. So I got plus or minus 1 over 1, which is 1. And then I do 1 over 2, so I got a plus or minus 1/2. So that's actually 4 potentials right now. Okay, and then I have plus or minus 5 over 1, and then plus or minus 5 over 2. And there's no overlap. There we go. That's actually 8 different zeros. Okay, and then you can look at the solutions for 55. I hope these videos have helped.